Hello guys, welcome back to my channel Junior Doctors, where concepts made crystal clear. Hope you gone through the anatomy as well as the functions of respiratory system. In this video, we are going to study the mechanism of respiration. Do you know why the intrapleural pressure is always negative? Do you know why inspiration is an active process whereas expiration is a passive process? In this video series, we are going to study these questions. Let's focus on the muscles of respiration, various movements taking place during the inspiration and expiration. We are also going to see the pressure in the lungs, the pressure in the pleura and the pressure in the alveoli. We are also going to see the pressure and volume changes occurring during the process of inspiration as well as the process of expiration. So let's get started. Broadly speaking, respiration occurs in two processes. The first process is inspiration, wherein the lungs and the thoracic cage enlarges and the air moves in. Second process is the expiration, wherein the lungs and thoracic cage takes its pre-inspiratory position and the air moves out. Certain muscles are involved in both of these processes. They are again divided into two types of muscles. Number one is primary muscles and number two is accessory muscles. Now what do I mean by primary muscles? Primary are those muscles which are essentially needed during that process, and the accessory are those muscles which are required during we are doing forced inspiration or forced expiration. So let's see the names of the muscles involved in inspiratory process. And as I have discussed, they are again divided into two. That is primary inspiratory muscles as well as accessory inspiratory muscles. The primary inspiratory muscle covers diaphragm and external intercostal muscles. Mind well, here in inspiratory process, external intercostal muscles are involved. The names are vice versa. Accessory inspiratory muscles. This involves sternocleidomastoid, scalene, elevators of scapulae and pectorals. Now let us focus on expiratory muscles. First comes the primary expiratory muscle. As I have mentioned that the expiration is a passive process, so there is no involvement of any muscle during quiet expiration process. Accessory expiratory muscle. These muscles are useful when we are doing forced expiration, and these are abdominal muscles. We will see these abdominal muscles in detail while we are discussing the forced expiration process. But another important structure I want to explain you here is the thoracic cage. The thoracic cage is formed by four important components. First one is thoracic lead. It is formed by manubrium sterni and the first rib. Second important structure present in thoracic cage are upper costal series. Third important structure is the lower costal series. Upper costal series involves ribs number 1 to 6. And the last and the most important structure of thoracic lead is diaphragm. Up till now, we have discussed the muscles of inspiration as well as expiration. We also divided it into further two more groups, that is primary muscles and accessory muscles. Now, before starting the actual process of inspiration and expiration, that is typical mechanism of breathing, let us discuss something about the pleura, its pressure, why it is negative and how it becomes negative. So, as you can see in the diagram, this black color are our lungs. The thick line shows the visceral pleura, which is highly attached to the lungs. This blue color line shows the parietal pleura, and this beautiful space shows the pleural space. This space is filled with a pleural fluid, which is a serous in nature. So, before starting the whole process, let's see the pressures at different levels. Firstly, the pressure inside the lung, which we mark it as P pulmonary, or we can say intra-alveolar pressure. It is about 760 millimeters of mercury. The pressure inside the pleura, that is here, it is slightly less than the intra-alveolar pressure. Let's suppose it is about 756 millimeter of mercury. And the pressure in the atmosphere, which is about 760 millimeters of mercury. Why this pressure is less, and as I said, why this is negative, let us focus that. If we want to see the difference between these, we need to subtract one from the other. So let us subtract P pulmonale from the P atmosphere. So 760 minus 760 millimeter of mercury, it is 0. So I can also write P pulmonale as 0 millimeter of mercury. Now let's take the difference between the intrapleural pressure and the atmospheric pressure. That is 756 minus 760, which is about minus 4 millimeter of mercury. Now why this pressure is negative? What makes it negative? And why we want this negative? So there are 4 reasons which makes it negative. Number 1 is elasticity of lungs. Number 2 is elasticity of chest wall. Number 3 is surface tension. And 4th one is gravity. Before discussing these reasons, I want to underline an important law which shows the relation of pressure with volume, which is given by Boyle, and famously it is known as Boyle's law. Let us see that. Pressure is equal to volume. No, this is not correct. Pressure is inversely proportional to the volume, which says that if volume increases, the pressure decreases, and the vice versa. If the pressure increases, then the volume decreases. Right? Let's apply these law in these 4 reasons. Now what is elasticity? Elasticity is the thing when we want to stretch something, it wants to recoil. And we all know that lungs are made up of elastic tissue, so they want to recoil. If lungs recoil, what happens? If lungs recoil, it will move away from the parietal pleura. The visceral pleura will move away from the parietal pleura. So the volume here increases, whereas pressure here decreases. So let us write that volume increases and pressure decreases. Next is elasticity of chest wall. We have seen that during the process of inspiration, the chest wall itself expands so that the air can move easily to the alveoli. So during expansion, what happens? During expansion of the chest wall, the parietal pleura moves away from the visceral pleura. Here also, the volume increases and the pressure decreases. Third one and the important reason is surface tension. Now what is surface tension? It is the interaction between the fluid and the gas molecule inside the alveoli. The tension which is generated by both the forces is known as surface tension. What happens here? The fluid inside the alveoli will try to take the alveoli inside, that is, it tries to collapse the alveoli. That's why the volume increases and the pressure decreases. The alveoli here will move inside. That's why the volume increases whereas the pressure decreases. The fourth and the important reason is gravity itself. Now let's suppose I yank or I pulse these lungs downward. What happens? The volume here in the apex will be increased, whereas the pressure here decreases. Similarly, what happens here downside? Here the volume decreases and the pressure increases, which shows that the intrapleural pressure is not uniform everywhere. Let's suppose it is like -4 here, -2 here, -6 here. So it is different at different points. These are the reasons which makes the intrapleural pressure negative, and we want that the lungs cannot get collapsed, so the intrapleural pressure remains negative. So these are the reasons, and we have discussed it in detail. Hope you have understood this well. Study well, enjoy learning. Let's meet in our next video. But don't forget to subscribe my channel Junior Doctors, where concepts made crystal clear.